Okay, sweet. My name is Tim Conkling, and I am an indie developer here in San Francisco. I'm developing an asynchronous multiplayer game right now, and I've been doing a lot of thinking about rapid prototyping of persistent multiplayer games. So I'm just going to jump right in. I'm going to jump in, with just a quick definition. So when I say persistent multiplayer, I'm specifically talking about multiplayer games that involve a client and a server, where individual play sessions or individual games can span multiple play sessions. And when you have a game where games can span multiple play sessions, you need to have a server that can store game state. So there are, MMOs are examples of persistent multiplayer games, check-in style Facebook games, asynchronous multiplayer games. These are all persistent multiplayer games. And when I talk about, rapid prototyping, I am essentially, I'm talking about the idea that there's always friction between having an idea and realizing that idea in your game. And rapid prototyping, for me at least, is basically the practice of removing that friction whenever possible. So like the goal of rapidly prototyping your game is to have the smallest turnaround time between game iterations. So there are a ton of points of friction in any game, and there are additional points of friction when you're making a multiplayer game. And I am focusing on two specifically in this talk. The first point of friction is data marshaling, and the second point of friction is the need to have an authoritative server. And click. And so data marshaling, so this right here, this is like a really simplified view of what a traditional persistent multiplayer server setup looks like. So on the left side of this diagram, you have your database, and that's where your game state gets persisted. And on the right side, you have your client, which is what the player sees, and that's the player's interface to the game. And in the middle, you have your server, and the server's job is to take data out of the database, ship it over usually a network to the client, and also receive commands from the client and validate those commands and send them back into the database. And the reason that this is a point of friction is that there are potentially different formats that you're using in each of the programs that are implementing each of these components of your game, right? So I'm using the term data marshaling also like somewhat loosely here. It refers to the process of like taking data that's in a memory format and converting it to a network or storage format, but I'm also using it to basically mean the process of mapping between different data formats. And what I mean by that is like when you have a database, your data looks different in a database than it does in your server runtime, and it potentially looks different in your server runtime than it does in your client runtime. And so the friction here basically comes from the fact that when you're iterating on a game, when you don't know what the design is, your data is constantly in flux. So imagine that you have a multiplayer game, and there's a hero object in this multiplayer game, and there's no notion of mana, but you want to add mana to the game. And in a single player game, that basically means, like, aside from all the game logic, you need to add a mana field to your hero object. But in a multiplayer game, you need to add a mana field to the hero object on the client. You potentially have to add the mana field to a different hero class on your server, and you probably have to, if you're using a traditional database, you probably have to add another column to your hero table. The other thing that you need to do is you need to make sure that these representations of the hero's mana stays consistent throughout all components of your game. So it's a huge pain in the ass, and the first to manage the relationships between all of these data And the first way of tackling this basically is choosing a good wire format. So there are lots of reasons to choose different wire formats, but when you're prototyping a game, I think the only things that really matter are you want a data format that you can use identically, essentially, on the client and the server. So if I'm adding mana to my hero object, my hero class, I want to be able to say hero.mana on the server and hero.mana on the client and have them mean the same thing. And I also really don't want to maintain serialization code. So if I'm shipping my data across the wire from the server to the client as XML, for example, there's probably a hero element, and I don't want to have to manually add the mana child to that hero XML element. Nothing else, I think, when you're prototyping matters, like the speed or the size of the format you're using. Because chances are you're just playing this game by yourself or with a small number of playtesters. So for the game that I'm working on right now, I chose Google Protobuf as my wire format. And Protobuf was developed by Google, and it's sort of, from what I understand, basically the lingua franca of like all services that are run inside Google and also outside Google. Their internal apps and their external apps use Protobuf, and it's open source. It's a format that has a pretty wide variety of implementations for different languages, including the two that I'm using with my game, which are ActionScript and Python. But I'm using Protobuf, but really it doesn't matter. There are a bunch of languages or libraries rather that essentially do what Protobuf does. I'm just using it as an example in this. So the way that Protobuf works and the way that that other Protobuf-like data formats work is essentially you maintain a set of files, a set of like .proto files that contain data descriptions of the data in your game, and these data descriptions look essentially like a struct does in C. So this is an example of something in my game where I was adding mana to a hero. You write a very simple data description file. You run it through a code generator that generates code for both your client and your server. And then the code generator basically pops out classes that you can use both on the client and the server that know how to serialize themselves, that know how to basically ship themselves over the wire to the client and the server. This essentially solves the two requirements that I have for a wire format for rapid iteration, at least, which is I'm using essentially the same format on the client and the server, and I'm also using a format that doesn't require me to maintain separate client and server classes when I update something about my data. But the bonus about using Protobuf, or really any of this sort of like family of interface description language data formats, is that it's also very fast and small, so you can continue using it like when your game goes to production, and it's also easy to read and write to disk. The second part of avoiding this friction is basically like avoiding databases altogether, right? So databases are good for a handful of they're good for a number of reasons, but when you're prototyping, none of those reasons really matter. So I will argue that like you should not use a database at all, if possible, when you are prototyping your multiplayer game, and instead use Protobuf as the data format, Protobuf or something like Protobuf, for each component of your game. So essentially, Protobuf you can use on the client and the server, but you can also just write it to disk, and then the files on disk become your database. And there's no custom marshaling. So this takes care of the data marshaling point of friction. And it also kind of takes care of the authoritative server point of friction, or at the very least, it makes the authoritative server point of friction easier to deal with. So an authoritative server, it's essentially, I mean, it's a very, very common design pattern in multiplayer games where the server is the owner of all of the game data. And generally the way that this is implemented is that the server exposes some sort of network API that, that clients use to make changes in the game. So back to like the hero and the mana example, you can imagine you've just added mana to your hero and you want the client to be able to update that mana. So in sort of a traditional setup, you might add a service call on your server that the client can call saying, you know, update my mana, or I've casted a spell or something like that. And then the server basically, you know, looks at what the client is trying to do, validates it, makes a change to the data, and then the client and the server are both responsible for ensuring that like the data ends up in the right state. This is another point of friction because you're essentially like duplicating your update logic across both the client and the server. But again, Protobuf and not caring so much about like whether people can do bad things, I guess, in your game, solve this problem. And essentially the way that you solve it is just by not having an authoritative server, and rather than having a set of APIs saying, I want to, you know, I, the client, want to tell you, the server, that the hero just updated his mana. You just have the client update that Protobuf object and ship it back to the server. And so essentially there's a single API on the server which is like, apply this change that I just made. And that is pretty much it. So finally, like there's some sample code that I threw up on GitHub that essentially is like it's a really dead simple Python class for pretending that that a bunch of Protobuf objects that you're reading and writing to disk are actually rows in a table, and it's been useful for me. And it handles things like, you know, concurrent access and loading and saving when the thing starts up and shuts down. But basically, like this is something that you may want to use, but it's a bonus. Anyway, that's the end of the talk, and yeah, please ask me questions afterwards if you have them.